Okay, problem 32 refers to problem 3. And so, what is the gravitational potential energy of the two particle system? Okay, so that's simply going to be U sub G is equal to minus big G M1 M2 over R. It separates them. Okay, that's part A. Now, if we triple the distance, if we go from 19 to 3 times that amount, what is the work done associated with that? So that'll be the change in potential energy. So if we go the potential at the initial position 19 and we subtract that from the potential at 3 times the distance, that should give you the change in potential energy or the amount of work done. So I'm going to give you the number, and it's approximately 2.92 times 10 to the negative 11. Okay, so that'll be the work required to triple the distance between those two. But I'll let you figure out what gets substituted in those two expressions. Okay, and then part C, the work done by the external force and by you. So that should be the same number but positive. So assume positive 9.2, and you don't have to reinvent the wheel. It's the same answer, but show in your solution how you got that number. All right, next problem. Okay, a certain binary star system. Each star has the same mass as our sun, and they revolve around their center of mass. The distance between them is the same as the distance between the Earth and the sun. What is their period of revolution in years? Well, okay, here's the binary star. Apparently, half the stars that you see up there in the sky are binary star systems. I'm just saying. Okay. So here's M1 and this is M2, and they're revolving. I'm just assuming, here's this binary system revolving about their center of mass, and they're both the same mass. So M1 equals M2. All right, now pay attention. This is subtle. So we're going to associate the centripetal force, okay, equals the gravitational force. All right, this is kind of odd. So the gravitational force will be dictated by the total distance that separates these two stars, but the radius of revolution will be half that distance. Okay, so make sure you keep that in mind. Now I'm just going to set up the general expression. I'll let you plug and chug the rest. So the centripetal force is mv squared over r, okay, because it's uniform circular motion, and that's equal to big G m1 m2 over, now in this case, d squared. Okay, so that's the distance between the two stars, which is approximately the distance between the Earth and the Sun. Now, the substitution you have to make here for speed, okay, that's going to be 2 pi r over the period. All right, so there's your helpful hint. So you're going to sub in 2 pi r over the period for v, and then reconcile the rest. Now, here's the period of revolution after it's all said and done. You should get approximately, okay, you got to show how you got this number. You're going to get approximately 2.2 times 10 to the 7th seconds, which is approximately 0.69 repeating years. So about less than a year is the revolution of that binary star system. Okay, next problem. Projectile is fired vertically from Earth's surface with initial speed of 10 kilometers per hour. So we're going to fire this projectile up 10,000 meters per second. Okay. Neglecting air drag, how far above the surface of the Earth will it go? Well, the state of energy at the surface of the Earth call that state 1, is equal to the state of the energy once the projectile reaches the highest point above the Earth. Now, here's the subtle, comparison here between these two states. We have 1/2 mv squared plus. Now, it's got gravitational potential relative to the center of the Earth. So we're going to call that minus g, mass of the Earth, the mass of the projectile divided by the radius of the Earth. So you have to take that into account. That's equal to, once the projectile gets to the highest point, it doesn't have kinetic energy, but it does have gravitational potential energy, universal gravitational potential energy. So that's going to be G M M over, now this is the R taken from the center of the Earth out to that location above the Earth. So we're going to call that raised to the Earth plus the altitude. Okay, so that's at state 2. Now you can cancel one of the m's, okay, the mass of the projectile. And then you're going to solve for h, okay, given all the given quantities and fundamental constants. And you should get, and I'll show you how you got this, you should get approximately 2.55 times 10 to the 7th meters. All right, there's your helpful hint for the rest of the homework. Enjoy the weekend, as I said. Have fun in the sun, then do your homework.